So now that we've memorized all the angles going around the unit circle in degrees and in radians, and we definitely remember all of them in all four quadrants, we got to think about how we're going to use this information. And we're going to use this information the same way we always use math information in math class when we're learning operations, in this case, functions, when we're learning functions. It's just going to be a 2 out of 3 game. We're just playing a 2 out of 3 game. And here's how math works. Here's how most of your math classes have worked. We've taken a piece of information. I'm going to start with one that you might be familiar with. We're going to take a piece of information. Then we spend some time convincing you that this piece of information is true. This is just true by definition. This is what we call 2. This is what we call 3. This is what we call plus, and this is what we call 5. And that's what equals means, right? So we know that 2 plus 3 equals 5. Then we learn variations on this theme, like Pachelbel's canon. So first you learn just the notes, because you play cello and you just learn that one sequence. So you learn this piece of information. Then you start learning variations on this theme. Then you learn about this thing called subtraction. And so you'll say 5 minus 3 is 2. Or 3 is equal to 5 minus 2. It's just the same piece of information rearranged. And then we bring you into an algebra class, and then we ask variations of this question by saying, what plus 3 is 5? We're using the same piece of information, but for some reason, we definitely make you write this first one. We say subtract 3 from both sides. And it's just a 2 out of 3 game. There's a 5 and a 3, and I use the word plus. What's missing? 2. Then you just learn more stuff, the one that I always use. let's do 7 times 8 is equal to 56. And then you learn some variations on this. That means that 7 is 56 divided by 8, or 8 is 56 divided by 7. And then we set up algebra versions of this same piece of information that hinges on the 7 times 8 is equal to 56. And I'll say 7 times what? Is 56. And I'm really asking you to remember 7 times 8 is 56. When I write 7x equals 56, I'm saying 7 times blank equals 56. And I'm trying to get you to remember 8. Yeah, 8. And then we like to remind you of how this is related to other things. It's like, oh, we know this is true because we could divide both sides by 7. Going to this one this time. So it's 56 divided by 7 is 8. Because first we taught you 7 times 8 is 56. We taught you how division and multiplication interact. 7 times 8 is 56, and 56 divided by 8 is 7, and 56 divided by 7 is 8. We're just expanding on this same kind of stuff. We've talked about sine of 30 degrees is 1/2. 3 things running around here: the trig function, the angle, the ratio. Sine of 30 is 1/2. So if I leave one of these things blank, and let's say ask the question, I forgot what color I'm on. Here we go. We learned to rearrange this. So sine of 30 is 1/2, and we know that we can use inverse trig function to find an angle. So 30 degrees is sine inverse of 1/2. So I can put this into an equation. We're going to do the same thing. We're going to take all this information that we know, sine, cosine, and tangent going all the way around the unit circle, and we've got to learn it in degrees and radians. Because we have a variation on this piece up here that says now sine of pi over 6 is equal to 1/2. So that pi over 6 is another sine inverse of 1/2. 2 out of 3 game. It's still a 2 out of 3 game. There's just the angle to be represented with degrees or radians. I messed the color up. It's supposed to be purple. That just made trig harder for the rest of the year. Try to save it with a little bit more purple there. So we want to look at a slightly more advanced version of this game, but it's still going to be a 2 out of 3. It's going to be a 2 out of 3 plus some additional information. This is the trig version of the 2 out of 3 game. I'm going to ask a question like sine of theta is 1/2. It starts off with a 2 out of 3 game. Sine and 1/2, what's missing? 30 degrees. Or in radians, what's missing? Pi over 6. So depending on which we're using, 30 degrees is missing. So we look at this and say, the missing piece of information is 30 degrees. I use theta, so I'm probably working in degrees because I typically use theta for degrees and x if I want radians, but I'll always specify. But then we got to stop and say, hang on a second. Sine is positive 1/2, and there are 2 places where sine is positive. Sine is positive in the first quadrant and the second quadrant. So we have an advanced form out of the 2 out of 3. It's kind of more of a 3 out of 4 now. It's 30 degrees, but sine is positive in the first 2 quadrants. Sine, so we got 30 degrees in quadrant 1 and quadrant 2, because sine is positive. The 2 out of 3 game gave us the 30 degrees. The fact that sine is positive in quadrant 1 and quadrant 2 means we need to take this 30 degrees and put it in quadrant 1 and quadrant 2. 30 degrees in quadrant 1 is just 30 degrees. What's 30 degrees in quadrant 2? 150. 2 solutions, 30 and 150. Two out of 3 game plus. Just another extra step. We got to think about quadrants because there's a couple of angles that we get. If we did the problem in radians, I'm starting to run low on space here. If we did this problem in radians, I might say sine of x is 1/2. What angle are we talking about in radians? Sine 1/2, what angle is it? Pi over 6. It's 30. So I wasn't going to be able to switch, so I just kept the same thing. So we're going to say x is pi over 6, but sine is still positive in quadrant 1 and quadrant 2. So I'm going to do pi over 6 in quadrant 1 and quadrant 2. So x will be pi over 6. And then the 30 degrees in quadrant 2 is 5 pi over 6. This is going to help us moving forward, understanding how these functions work. We're trying to build an understanding about how sine and cosine and tangent operate as functions. If I change out one of the parts, it's 2 out of 3 game. So let's change out one of the parts. What if I said cosine of theta, theta's in degrees, is equal to 1/2? What angle are we talking about now? 60 degrees. Now our angle is 60 degrees. And cosine is positive 1/2. Where is cosine positive? Quadrant 1 and quadrant 4. So what's 60 degrees in quadrant 1? That's the easy one. All right. That one's 60 degrees. And then 60 degrees in quadrant 4, because we have this picture in our mind, 60 degrees in quadrant 4 is 300. With cosine and the 1/2, we're thinking 60 degrees. Cosine and positive, quadrant 1 and 4. We look at a variation of this problem. We got cosine and 1/2. What's our angle? 60 degrees. Cosine and negative. What are our quadrants? 2 and 3, because that's where cosine is negative. Cosine is negative where x is negative. X is positive in 1 and 4, so negative in 2 and 3. So we just got to take 60 degrees and put it in quadrant 2 and quadrant 3. 60 degrees in quadrant 2 is our 120, and 60 degrees in quadrant 3 is 240. It's just 2 out of 3 games. And one of them has 2 answers. And we have to be able to do this in degrees and in radians. So if I'm like, oh, cosine of x is negative 1/2. Now, instead of 60 degrees, we're going to do the problem in radians. What's 60 degrees but radians? Pi over 3. Ideally, you just automatically think in radians, but if you go through degrees, that's okay. We're just learning. It's like when you're learning a language, like someone says something to you in Spanish, you translate it into English in your head, you come up with your English response, you translate that to Spanish and you send it back, and it takes extra time. It's ideal if you just hear it in Spanish and respond in Spanish. So it's ideal if you just think pi over 3 because I said radians. But if you're like, oh, no, 60 degrees, that's pi over 3, and now I can fix it. Our quadrant is still the same. Cosine and negative still tells us quadrant 2 and quadrant 3. So now we need our pi over 3 in quadrant 2 and quadrant 3. We're learning the unit circle all the way around so we can come to these conclusions quickly. There's a couple of conclusions that we need to come up with because these quadrants. Any questions? How's everybody okay? They look so very sad. We're going to reinforce this more once we start graphing these functions. So we may or may not remember. But cosine kind of looks like this. And sine kind of looks like this. They do this forever and ever, but if we pick a 1/2, let's see here, the middle. If we pick this 1/2 that we've been using, there are 2 cosines in the first and fourth quadrant, the first and fourth quadrants. And if we do the same thing with sine, there are our 2 answers for the 1/2 in the first and second quadrants. So learning the unit circle and all the values, where things are positive, helps us picture the graphs when we start applying these trig functions to real numbers, and we start modeling things that have sine waves as a function. Cosine always looks angry. And when I draw sine under here, the sine looks scared of cosine. Cosine looks angry because the angles are like eyebrows, like oh, and then this one, because it's like, oh, like this, it's like, oh no. Am I the only one? Yeah. Uh-huh. Uh-huh. So this is the radians version of the problem above it, right? So cosine and the 1/2 made us think of 60 degrees. We also want to think in radians. So cosine and the 1/2 make us think pi over 3. That's just another way of saying 60 degrees, right? Okay. And then then the next thing we did a second part. Cosine and negative tells us quadrant 2 and quadrant 3. So in the first problem, I said 60 degrees in quadrant 2, that's 120. 60 degrees in quadrant 3 is the 240. I'm using the 60 degrees as a reference angle. So now that we have radians, pi over 3 is our reference angle in quadrant 2 and quadrant 3. We're just doing the whole thing over again, but in radians. So instead of saying 60-degree reference angle in quadrant 2 is 120 degrees, we're saying pi over 3 radians in quadrant 2 is 2 pi over 3. That make sense? So we get a reference angle based on the trig function and the value. We get 2 quadrants based on the trig function and the sine, plus or minus. And that's the game that we're trying to play. Because we're trying to learn our way around functions that have these sine wave shapes. Any question? How's everybody okay? I'll put that in the notes. People will not know what they don't want to do. People are just reading the notes, not watching the video. Any questions, comments, my remarks? Not a very good YouTube. Smash that subscribe button. And then tell you, only 60% of you that watch the videos are subscribed. I'm not going to read through my analytics. It's cute that YouTube gives me my analytics, even though they don't mean shit, because I only have like 50 subscribers, and that's just because a bunch of my students from previous semesters forgot to unsubscribe. That's okay. All right, that's gonna do it for today. That's gonna do it for this week. Your goal over the weekend is to learn your radians, the radian version of the unit circle, and connect it to the degree version of the unit circle. And think about trig function, angle, ratio. And also quadrant and sine, plus or minus. That's going to do it for today. That's going to do it for this week. I'll see y'all on Tuesday. Everybody have a good long weekend, and thanks for playing.